So we saw that the alternating series test does not always do the trick. If the three conditions are satisfied, then we're good. If the third condition isn't satisfied, we're able to make an nth term argument. But if the third one goes to 0 and maybe one or two in those conditions fail, we're kind of stuck. But we do have one more option, and that's what's called the absolute convergence test. And it says that if instead of looking at the original series, you look at the series of the absolute value of the terms, if that converges, then the original converges. So this can be useful. And I'd like to make an argument for why this is true. So let's think about how we can compare the terms of those two different series, the original one and the absolute value. Well, first of all, what's true of all numbers, every number is trapped between its absolute value and the negative of its absolute value. Think about that for a second. If for any number, if it's already positive, then it is its absolute value, right? So then it's technically equal to, but it's less than or equal, that's fine. And if this number is negative, taking its absolute value and its opposite will really be what this is, right? Because if this is negative, taking its absolute value would make it positive, and then that makes it negative again. So whether this is positive, when this number is positive, it is its absolute value. When this number is negative, it is the opposite of its absolute value. So you could really say this about any number. This isn't really anything specific to series. This is true for any number is trapped between its absolute value and negative absolute value. So let's start off by doing a little manipulation. I'm going to add the absolute value of a sub n all the way through here to get a new inequality, 0 less than or equal to that, less than or equal to 2 absolute values of a sub n. Now, we're starting to get something that looks like direct comparison, right? I've got something that's greater than or equal to 0 and less than or equal to this. But our theorem says, so say the absolute value of our terms converges. Well, we know from our properties of series that when you take a constant multiple, that's also going to converge. So we're getting closer. Now this isn't quite our series yet, but we'll be able to get there. So we know that the series then, that series converges by dct. By a little clever manipulation there, we've made an argument about convergence, but it's not what we wanted, right? I want to get to the original series. This isn't quite it. So another little algebra trick here. Our series could be written as this, right? I've just added in something and taken it right back out. But we know from our properties of series that as long as it's convergent, it would be equal to this, right? That was a property of series that you can break up addition or subtraction so long as they're convergent series. Are these convergent series? Well, yes. We just proved that one's convergent. And that was our assumption that this one was convergent. So we have the difference of two convergents, both those guys converge. So that series converges. So it all starts with this idea. This is a nice idea, actually, in general, when you're dealing with things that could be positive or could be negative. And you can just think about why this might be a useful tool in other areas. Think about sandwich theorem. A lot of times you might be able to make an easier argument about an absolute value. So by trapping it between its absolute value and its negative absolute value. But here we used it to get a direct comparison test going about series. And kind of in an indirect way, not an obvious way, but worked out there. So keep in mind, in using ACT, if you take the absolute value of your series, the terms, and it converges, then you know the original series converges. If you take the absolute value of the terms of your series and that series diverges, this theorem says nothing. So you've got to try something else. So don't make that mistake. This test will only tell you convergence, or it'll be inconclusive.